Think of the memory you're most certain about, a moment that feels burned into you, a conversation that changed everything, something you've told the story of 100 times. You know exactly how it went. You can see it. Now consider this. The version you just recalled is not the original, it's the last edit. Most people operate on the assumption that memory works like a video camera. The event happens, the brain records it, and from that point forward, the recording is stored somewhere waiting to be retrieved when you need it. You remember the event. You don't change it. You just play it back. This model is wrong, and the experiment that proved it wrong happened in a rat's brain, in a lab in New York, and it should make you quietly uncertain about almost everything you think you know about your own past. In the late 1990s, a neuroscientist named Karim Nader was working as a postdoctoral researcher in Joseph Ledoux's lab at NYU. His supervisor told him the idea he wanted to test was probably a waste of time. Nader did it anyway. Here's what he did. He trained rats to fear a specific tone by pairing it with a mild electric shock. The rats learned quickly. They froze in fear every time they heard it. Then Nader waited. He let the memory consolidate, settle into the brain's long-term storage, where it was supposed to be stable and fixed. Then he played the tone again, not to scare the rats, just to make them remember. And the moment the memory was retrieved, he injected a drug directly into the rat's amygdala, the region of the brain responsible for storing emotional memories. The drug blocked the brain from building new proteins. And what happened next overturned 30 years of consensus about how memory works. The rats forgot the fear. Not because the memory was old, not because the drug erased it in storage. The memory had been there, stable, for days. What made it vulnerable was the act of remembering it. The moment the rats recalled the fear, the memory briefly destabilized, returning to the same fragile, unfinished state it had been in right after learning. And in that window, the drug wiped it. The same drug, injected without triggering the memory first? Nothing. The memory stayed intact. Nader published his findings in Nature in 2000. The conclusion was simple and radical. Consolidated memories, when reactivated, return to a labile state and must be rebuilt. Every time you remember something, your brain doesn't just retrieve the file. It opens it. And when it closes the file again, it's not saving the original. It's saving the version that was open, the version that was sitting in your mind, interacting with everything else you know and feel and believe right now. Memory is not playback. It's reconstruction. And reconstruction introduces errors. Elizabeth Loftus has spent 50 years studying exactly what those errors look like. In one of her most famous experiments, she showed participants footage of a car accident. Afterward, some were asked, how fast were the cars going when they hit each other? Others were asked the same question, except the word hit was replaced with smashed. One word. That's all that changed. The smashed group estimated the cars were going significantly faster. And a week later, when asked whether they had seen broken glass in the video, there was no broken glass in the video. The smashed group was far more likely to say yes. A single verb, delivered after the event, had modified what people believed they had witnessed. That's the misinformation effect. And it's not a flaw specific to people who are confused or unreliable. It works on everyone. Loftus took it further. Working with her colleagues, she attempted to implant an entirely false memory, an event that had never happened at all. The target memory, being lost in a shopping mall at around age 5 or 6. Participants were given a booklet of short descriptions of real childhood events provided by their families, along with one fabricated event, the mall story. About a quarter of participants not only accepted the false memory as real, they began elaborating on it. They described the stranger who found them, the feelings of panic, the reunion with their family, memories that had never happened, built out of nothing, complete with sensory detail and emotion, because the suggestion had been planted and the brain had done the rest. Here's the part that almost nobody includes when they tell this story. Elizabeth Loftus, the world's leading expert on false memory, the person who built a career demonstrating that human memory is unreliable, had a false memory implanted in her own mind by her cousin at a family gathering. The cousin mentioned that Loftus had been the one to discover her mother's body floating in a pool. Loftus started to remember. The image came to her. The details arranged themselves. She began to feel the weight of a memory she had apparently buried for years. A week later, the cousin called back. It hadn't been her. The woman who wrote the textbook on this had just experienced it herself. Scientists are still working out the full extent of what this means. We don't know precisely how much each retrieval changes a memory. We don't know which memories are most vulnerable, or how many retrievals it takes before the accumulated drift becomes significant. What we do know is that the model most people carry, memory as storage, retrieval as playback, certainty as accuracy, is not correct, which brings you back to the memory you started with, the one you're most certain about. How many times have you remembered it? How many times has your brain opened that file and closed it again, each time saving a slightly revised version shaped by everything that had changed in you since the last time you looked? Here's the question that's harder to sit with. If your memories are reconstructions, edited and re-edited by the person you were at each moment of recall, then you are not, technically, the sum of what happened to you. You are the sum of how you've remembered it. The story you've told yourself 100 times about who you are and what your life has been, which might be more accurate than the objective version, or might be more distorted. Almost certainly it's both, in ways you can't fully distinguish from the inside. The eyewitness problem makes this concrete. More than 70% of wrongful convictions later overturned by DNA evidence in the United States involved eyewitness testimony. People who were certain. People who sat in a courtroom and pointed at someone and said, "I remember. I was there. I know what I saw." And they believed it completely because memory feels like fact. Certainty feels like accuracy. The vividness of a recollection, it turns out, tells you almost nothing about whether it's true. The video camera is running. You just can't trust the footage.